Section: Introduction. In this section, we will discuss the significance of large language models, LLMs, in various applications such as question answering, content generation, translation, and code completion. These advanced models like ChatGPT, Gemini, and Claude have transformed how people interact with technology, making it more efficient and effective. However, operating the most advanced LLMs can be expensive. Currently, online advertising plays a crucial role in supporting digital content and services. While LLM services typically operate on a subscription basis, there is a growing interest in exploring whether advertising could help offset costs for users. We aim to develop auctions that can allocate online ads within LLM outputs using the Retrieval Augmented Generation (RAG) framework. RAG enhances the reliability of LLM-generated content by first retrieving relevant documents from a database based on a user query and then using this information to generate the output. This framework can be extended to incorporate ads into the LLM output, potentially through prompt engineering. Our main focus is on designing auctions for ad allocation in LLM outputs. We introduce the concept of segment auctions, where ads are allocated for each segment of the output, such as a sentence, paragraph, or the entire content. The auction process involves retrieving relevant ads and bids, forwarding them to the auction, and implementing a randomized allocation rule based on these inputs. We explore both single ad and multi-ad allocation per segment scenarios. For single ad allocation, we show that the RAG-based allocation rule is optimal in terms of a new logarithmic social welfare (LSW) function, balancing economic efficiency and fairness. We also demonstrate how this allocation rule can be implemented truthfully using auctions. In experiments using LLM APIs, we compare the performance of single ad and multi-ad segment auctions against naive baselines. Our results show that while single ad auctions generate higher revenue, multi-ad auctions lead to higher output quality. We validate these findings through qualitative analysis of the output quality. Our work contributes to the growing interest in using auctions to influence LLM outputs, particularly in the context of advertising. We discuss the practical challenges and implications of implementing segment auctions and compare our approach with related works in the field. Section Summary. In this section, we introduce the concept of segment auctions for allocating ads within the output of large language models, LLMs, like ChatGPT and Gemini. These auctions operate based on the Retrieval Augmented Generation (RAG) framework, where relevant ads are retrieved from a database and incorporated into the LLM's output. By optimizing the allocation of ads per discourse segment using a randomized rule, we aim to balance economic efficiency and fairness, ultimately enhancing the quality of LLM outputs while potentially generating ad revenue. Section: Preliminaries. In this section, we formally define the model behind LLM auctions for ad allocation via RAG. We consider a set of ads indexed by numbers, where each ad is provided by an advertiser. Each advertiser has a private valuation for their ad being clicked. Advertisers submit bids to be shown in the LLM output to maximize their own payoff. When a user enters a query into the LLM, an auction mechanism selects an ad to advertise and generates an output that includes a mention of the chosen ad. The generation of the output is independent of the auction mechanism and the bids once the ad to advertise is decided. To understand how an LLM auction operates under the RAG framework, let's first look at how RAG works with a set of documents. Given a query, a set of documents can inform the output of the LLM. The output follows a generative model where the top documents with the highest relevance scores are considered. RAG can be fine-tuned for performance by adjusting parameters related to document retrieval and output generation. In the auction design under the RAG framework, we need to specify ad selection probabilities based on bids and prices for selected ads. We assume that RAG provides baseline ad selection probabilities given a query. The retrieval component is calibrated to the expected clicks an ad would receive under a query. Advertisers strategize before the output is generated, considering randomness in ad retrieval and output generation. The relevance of an ad to a query is measured indirectly. Advertisers are charged per click, but the auction works with expected prices per impression. The auction allocation rule is randomized under RAG. An auction defines an allocation rule and a payment rule. The expected utility of an ad before ad selection and clicks are realized is defined. An auction is dominant strategy incentive compatible if it is optimal for an advertiser to report their true value to the auction. It is individually rational if no advertiser is worse off by participating in the auction. Section Summary. In this section, we formally define the model for LLM auctions in ad allocation using RAG. Advertisers have private valuations for their ads and submit bids to maximize their payoff. The auction mechanism selects an ad to display based on bids, and the output generation is independent of the auction mechanism and bids. RAG's flexibility in considering different contextual inputs during output generation makes it suitable for integrating ads effectively. Section: Single Allocation Segment Auction. In this section, we introduce a segment auction within the RAG framework to manage ads during the LLM's output generation process. A discourse segment represents a group of tokens and serves as the smallest unit for the LLM auction. The segment size can be controlled by truncating tokens or prompt engineering. Initially, we focus on a scenario where one ad is included in each segment. Let T denote the number of segments. Our goal is to generate the TTH segment Y(T) based on the previous segment's Y(1), T1. For each segment Y(T), we can include one of K ads in the output. The RAG generative model adjusts the probability of including an ad based on the advertiser's bids. We assume that each segment is sufficiently informative on its own and that the advertiser's utility is additive across segments. The segment auction involves perturbing each agent's score using Gumbel random variables and then conducting a standard second price auction to determine the allocation and payment. This perturbation ensures that bidders win based on adjusted probabilities. Following the auction, the LLM generates Y(T) according to the model. In terms of theoretical analysis, we aim for incentive compatibility and individual rationality in the auction design. We consider independent segment auctions where relevance is independent across segments. Our results show that for this class of auctions, the RAG-based allocation maximizes a new logarithmic social welfare metric under truthful bidding. The segment auction is designed to be truthful and individual rational in expectation. It involves randomization over truthful second price auctions, with payments determined uniquely up to an additive constant. Section Summary. In this section, we introduce a segment auction within the RAG framework to manage ad retrieval and allocation in the LLM's output generation process. The segment auction focuses on generating discourse segments that can include ads, with the key concept being the incorporation of ads into each segment based on advertisers' bids. The auction mechanism ensures incentive compatibility and individual rationality, maximizing a new notion of logarithmic social welfare while considering the relevance of ads in each segment. Section: Multi-allocation segment auction. In this section, we focus on the setting where we want to advertise multiple ads in a single segment instead of just one. This can be more efficient if the segment is long enough to accommodate multiple ads or if there are several ads that fit naturally without affecting the segment's quality. Our goal is to design an auction system that can allocate and pay for multiple ads in a segment while meeting certain criteria. We start by looking at the auction process for each segment. We aim to select a certain number of ads, denoted as K, for each segment. This process is an extension of the single ad auction mechanism. The winners are selected from a set of possible ad combinations, and the final output generation is handled by a language model, LLM. The allocation function for this multi-allocation segment auction is characterized by a theorem, which generalizes the single ad auction. The multi-allocation segment auction is a special case of a more general combinatorial segment auction. In the combinatorial auction, Each set of ads is treated as a single unit, and a relevance metric is assigned to determine the allocation probability for each set. This metric considers both the set-wise relevance and the individual relevance of each ad within the set. While this approach offers a more natural connection with advertiser utility, it also increases computational and query complexity compared to the single ad auction. To validate our theoretical findings, we conducted experiments using numerical simulations. We tested different types of segment auctions, including those with and without ad replacement, as well as variations that incorporate relevance differently. The experiments involved running scenarios with different advertisers and bids, and we calculated various outcome metrics such as revenue, social welfare, and relevance. These metrics help evaluate the effectiveness of the auction mechanisms in practice. Section Summary. In this section, we introduce a multi-allocation segment auction that allows for multiple ads to be allocated within a single segment, addressing the inefficiency of single ad per segment approach. By designing allocation and payment functions, we aim to achieve desired properties in the auction mechanism. This multi-allocation segment auction is a generalized version of the single allocation segment auction, offering flexibility in selecting and integrating ads while considering relevance metrics, albeit with increased computational complexity. Section: Quality of output. In this section, we measure the similarity between the original outputs generated solely from the LLM and the modified outputs for each mechanism using cosine similarity. This similarity is normalized to a range of 0 to 1. When looking at auction outcomes, we consider a scenario with 4 ads having different probabilities of being allocated. Social welfare varies significantly across mechanisms. The segment auction with replacement has the highest social welfare, followed by the one without replacement, due to differences in efficiency among advertisers. The segment auction without replacement still performs better than naive 2 in terms of social welfare. However, the multi-allocation segment auction tends to have the lowest revenue because it charges lower payments to winners who receive multiple allocations at once. The segment auction with replacement is more relevant than the one without replacement, especially for the ad, Bookhaven, with high relevance. Naive 2 and the segment auction without replacement have similar overall relevance due to the small number of ads compared to available slots. For minimum social welfare, the ordering is different due to allocation probabilities. The segment auction with replacement repeatedly selects Bookhaven, while without replacement, different ads are chosen for each slot. Naive 2 has slightly higher minimum social welfare than the segment auction without replacement due to a more uniform selection procedure. Similar trends are observed in other scenarios detailed in the appendix. To assess output quality, we implement the multi-allocation segment auction, where the entire 3 sentences are considered a segment and 3 ads are allocated. Interestingly, we find that the multi-allocation segment auction shows the highest similarity among all mechanisms. This suggests that allowing flexibility in deciding where to place ads within the document leads to better articulation of the output without compromising quality. This effect is more pronounced with a higher number of advertisers, highlighting the superiority of the multi-allocation segment auction in terms of output quality. We conduct a qualitative analysis comparing single and multi-allocation segment auctions with 11 advertisers. In the multi-allocation segment auction, we observe that each ad is not necessarily advertised in every sentence. Ads like Massmart and Espresso Edge are placed coherently in the second sentence, while the first sentence addresses the user's query. The third sentence is constructed in a cohesive manner from the previous sentence. This demonstrates that the multi-allocation segment auction produces a more coherent output as the LLM can optimize over the entire document to place selected ads. In contrast, the single allocation segment auction forces each ad into a specific segment, leading to less cohesive output. Further qualitative analyses are provided in the appendix.